There are two special triangles that we will need to be familiar with and able to recall the ratios of the sides quickly. One is the 30, 60, 90 triangle. So if we have a case where we have a 60-degree angle, a 30-degree angle, and a right angle, then we have what we're going to call a 30, 60, 90 triangle. And something that we recall is that similar triangles are proportional. So we can define this triangle in infinitely many ways in terms of side ratios, but one that is very easy to remember is 1, 2, square root of 3. If we remember these three values and associate them with a 30, 60, 90 triangle, it is easy to figure out which side goes where. 30 degrees is the smallest of these three angles. So the side opposite 30 degrees should be the shortest side. The smallest of these three numbers is 1. So 1 would go here opposite 30 degrees. The hypotenuse is always the largest of the sides of a right triangle. 2 is the largest of these three numbers. So it would go here on the hypotenuse. And then that only leaves one spot left for the square root of 3. So then it becomes very simple to find the sine of, say, 60 degrees. If we're talking about this angle 60 degrees, then relative to this angle, the opposite over hypotenuse would be the square root of 3 over 2. The cosine of 60 degrees would be the adjacent over the hypotenuse, or 1 over 2. The tangent of 60 degrees would be the opposite over the adjacent, which would be the square root of 3 over 1, or just the square root of 3. We could also look at the sine of 30 degrees. Now, relative to this angle, 30 degrees, the opposite would be 1, and the hypotenuse would still be 2. The cosine of 30 degrees would be now adjacent over hypotenuse, square root of 3 over 2. Let's think for a second about the cosecant of 30 degrees. The cosecant is defined as the hypotenuse over the opposite. So that would be 2 over 1, or 2. The cotangent of 60 degrees. Well, let's see. The cotangent is the adjacent over the opposite. So that would be 1 over the square root of 3. And typically, we would go ahead and rationalize that denominator. So we would wind up with the square root of 3 over 3. Another triangle that we need to be familiar with is the 45-45 triangle. This triangle can be recalled by the fact that these two sides are going to be the same. And we can use the Pythagorean theorem to find the value of the other side of the hypotenuse, but we can use whatever numbers we want, and it's customary to use a 1, sometimes the square root of 2, but in either case, they're both going to be the same. So let's use 1s for now, since that's simple. And then if we use the Pythagorean theorem, we'll find that the hypotenuse would be the square root of 2. So the sine, then, of 45 degrees is going to be the same whether we use this angle or this angle. Its ratio, opposite over hypotenuse, would be 1 over the square root of 2. But then again, we would rationalize the denominator by multiplying the top and bottom by the square root of 2. And we would wind up with the square root of 2 over 2. The cosine of 45 degrees would be the adjacent over the hypotenuse. But then again, we find the same values since the sides are the same, and we would wind up with the square root of 2 over 2 after rationalizing. The tangent of 45 degrees, which is the opposite over the adjacent, would be 1 over 1, or just 1. The cotangent of 45 degrees would just be the inversion of the tangent, so adjacent over opposite, but that's still going to be 1 over 1, or just 1. The secant of 45 degrees is the inversion of the cosine, so hypotenuse over adjacent, which is going to be the square root of 2 over 1, or just the square root of 2. The same with the cosecant of 45 degrees. That will be the inversion of the sine, which will be the hypotenuse over the opposite, which again will be the square root of 2 over 1, or just the square root of 2.